Hi guys, we are just going to do one more little thing from Module 5, Investigation 5. So same section we were working on yesterday. Yesterday you had, we looked at this function. It was the very first problem we looked at. And it looked like that. And I had asked you what the roots were, and you guys correctly said -1 and +3. And then towards the end of the lesson, we talked about multiplicity, and that is basically how many times the factor is a factor. So x plus 1, that root, -1, has a multiplicity of 1. X minus 3, the root 3, has a multiplicity of 2. Do you remember what that means or how it affects your graph? So hopefully you are thinking if it has a multiplicity, if a factor has a multiplicity that is an odd number, you will cross the x-axis there. And if it has an even multiplicity, you will only touch the x-axis there. So at -1, because it has a multiplicity that is odd, it will cross. And at 3, because its multiplicity is even, it will touch. Okay, so that lets us start sketching a rough graph. So at -1, we know we're going to have a root, and at 3, we know we're going to have a root there. Okay, we know we're going to cross the x-axis here, but only touch it here. What we need to figure out, the next thing to add to your graph, is is your function positive or negative in these intervals? So clearly, because these are your only zeros, from -1 forever over here, you're never going to touch the x-axis. So you're always either going to be above the x-axis or below in that interval. Then from -1 to 3, you're not going to touch the x-axis, so the whole function's either going to be above or below the x-axis. Same thing for 3 to infinity. But keep in mind, you're only touching here, you're not crossing. So whatever this interval is doing, whether it's above the x-axis or below, this next interval is going to do the same thing. So your roots split your function up into intervals. How can we determine this? Well, you can use a test number. And one common way of doing it is making a sign chart. Okay, so first thing I'm going to do is I'm going to draw a little line. And on that line, I'm going to mark my zeros. So I know my zeros are at -1 and 3. And then over here, I'm going to list the factors. So my factors are x plus 1 and x minus 3 squared. And then under that, I'm going to have my entire function. And instead of writing the whole function, I'm just going to write f of x. All right, so now what we need to think about is what would the sign, if I plugged a number in from this interval into these things, what would the SIGN sign be? Well, down here I'd be having to plug in a negative number, smaller than -1, so maybe like -2. That could be a test point. If I plug -2 into x plus 1, I get a negative answer. I don't care exactly what the number is, I'm just trying to figure out the sign. If I plug a negative number into x minus 3 squared, well, say -2 minus 3 is -5, but -5 squared becomes positive. Would you agree that that would happen not just with -2, but with any negative smaller than -1? Yeah, these are always going to be a negative and a positive. So put that together, what would the sign of the entire function be? Well, a negative and a positive make a negative. So that tells me from -1 to infinity, my function is always negative. It is below the x-axis. I don't know what it looks like, I just know it's down here somewhere. Okay? All right, let's do the next section. So we're talking about the interval from -1 to 3. because I know I'm never crossing the x-axis between those. So maybe use 0. If I plug any number inside this interval into x plus 1, but maybe specifically thinking of 0, I'm going to get a positive answer. When I plug in here, the inside of the parentheses are going to give me a negative, but a negative squared is positive. I don't even really need to think about this, right? I know if I'm squaring, I'm always going to get a positive there. Two positives make a positive. So my function inside here is all going to be above the x-axis. Okay? I don't know what the maximum number is. I don't know what's happening. All I know is I'm up here. So I'm just going to do this. I have no idea what the y values are. All I know is I'm positive, but I also know I need to come back down here. So it's not the slope that's positive. It's the function value. Every single y value here has to be positive. Now we already said, because we know it's only touching here, that whatever this interval is doing, the third interval is going to do the same. But let's just check and make sure. Any positive number plus 1 is going to give me a positive. And I already know because this is squared, that's going to be a positive. So my entire function, a positive and a positive, gets a positive. So we were right. It is, in fact, positive. So I'm going to make it dip down to touch that and then keep going up. Other things we could think about is end behavior. This is a, connect that back up. This would be a third power, right? X times, there's going to be an x squared, so x cubed. And is this a positive leading coefficient? Sure, 1, 1, that's positive 1. So it makes sense that our left end behavior goes to negative infinity, and our right end behavior goes to positive infinity. We learned that yesterday. Okay, so again, this is a very rough sketch because I have no idea what any of the points are except for these 2 points. Other than that, I didn't find any other points. I just used the end behavior and the fact that I know positive and negative. All right. So let's try one more of these graphs. All right, so immediately we know what our roots are going to be. 0, -5, and +1. What power is this? Well, I see x squared, another x, and another x, so we're thinking x to the 4th. Is it a positive leading coefficient? Yes, look at your coefficients. 2, 1, and 1, that's definitely positive. So if it's an even power, both end behaviors are the same, and if it's positive, that means they're both up. I have no idea what happens in the middle of it at this point. I just know the end behaviors are both going to be up. Set up a sign chart. So our factors are 2x, x plus 5, and x minus 1 squared. And then we'll get the entire function, except for it's not f, it is g, or it's not g either, it's h. Okay. Set up your number line, marking your roots. -5, 0, 1. All right, so you need to think of plugging some number into each of these 4 things, well, each of these 3, and then you're going to get your final h of x that's in this interval. So somewhere from -5 to -infinity. So maybe you think of -6 or -10 or -50. It doesn't matter, just something in that interval. I'm going to ask you guys to pause the video and try to do the sign chart. And then when you're all ready or when there's been enough time, start playing it again. So please pause the video now, and then I'll go over the answer. Okay, so I am getting a negative, negative, positive. And I know actually all of these are going to be positives, right? Because it's something squared. negative, negative, positive. Two negatives is a positive, another positive, still positive. And that makes sense because we already know that the end behavior there is going to infinity, which means it's all above the x-axis, which makes it positive there. Again, this is not increasing, decreasing. It's literal, what are the function values? Are they positive numbers on your y-axis or negative numbers on your y-axis? Which of course then tells you, do they fall above the x-axis or below the x-axis? All right, continuing on, somewhere between 0 and negative 5, I've got a negative and a positive to give me a negative. Negative, positive, positive creates a negative. So in my next interval, I am down here. I have no idea where this point starts or stops. I don't know my y values. I just know it's below there. Next one, positive, positive, which is going to result in a positive. So I am above the x-axis for that interval, but of course I've got to come back down to the root. Now, I should know because my 1 has a multiplicity of 2 that I'm going to have to come back up, right? I'm not going to cross it, I'm only touching it. And I also know my end behavior. So there's two different ways to check and see what that is. A third way is the sign chart. Well, that would be a positive, which results in a positive. So I've now done 3 checks for this last interval. The end behavior, the multiplicity, and then the actual signs. Again, the y values we don't know, but we definitely know our x values. Okay. All right, so hopefully you are good on that. I'm going to ask you some further questions in the homework given the graph, but I think you are good. So tonight, I need you to finish that homework assignment that you had from yesterday and nothing else. So no pre-class, just the homework assignment.